Okay, so we're gonna continue talking about recursion. We started talking about this, really cool programming tool called recursion, which allows me to solve problems recursively. Yeah. So basically, if we look at summary of what is recursion, it's really about the following. Yeah. Basically, trying to solve a problem by making it a smaller instance of the same problem. So you have to do two things: define the base case, which is the very simple case, for your input, for which I know a solution already without any, sophisticated steps. And then you need to define also the recursive step, which means, right, try to do, like solve the problem, but on smaller instance. And how do I, implement the recursive step? You implemented by making the function call itself, right? Now, one thing we have to always be careful about to avoid infinite recursion, similar to, in loops, avoid, infinite loops, is to make sure that you have at least one base case, so one or more base cases that are easy to solve. Yeah. So basically, usually an if statement and return a particular value. And then you must make sure that your recursive step actually leads you to the base case or one of the base cases by reducing the input size until it reaches the base case. Yeah, that's in a nutshell. We looked at a lot of examples for doing this. Today and on Friday, we'll look at more and more examples. Is the lagging, is it happening? Okay, you're good, you're following? Okay, great. All right, so we stopped here. Fibonacci sequence. Fibonacci sequence is something that is by definition very recursive. So regardless of programming or anything, it's just something, a sequence that is defined recursively. What is a Fibonacci sequence? Anybody knows what is a Fibonacci sequence or a number? Can anybody tell me? Have you seen this before? Anybody hasn't seen Fibonacci sequence before? Can you hear me? Am I muted? No, I'm not muted, right? Not necessarily. It depends on how you define it, right? So F1 and F2, probably F1 and F2 is one. Yes, you're right. But some people started from F0, some people started from F1. Adam is saying, yes, it's a sequence, right? 1, 1, 2, 3, 5, 8, right? That's correct, yeah? It's just a sequence. What is a sequence? It's a, like a progression of numbers, yeah, that have a pattern. So in Fibonacci sequence, the pattern is defined as follows. You have the first element, so we start at 0 in this particular example. You can always start from 1. So f of 0 is equal to 0. F of 1 is equal to 1. So that's how I, bootstrap the sequence, the Fibonacci sequence. Okay, and now every other term, starting from 2 onwards, I can compute it using the previous terms. So f of n is equal to f of n minus 1 plus f of n minus 2. So if n is equal to 2, then f of 2 would be equal to f of 1 plus f of 0. So 2 minus 1 and 2 minus 2, that's f1 and f of 0. I know already f1 and f0, that's 1 plus 0, which is equal to 1. So as Rawad and Adam said, the third term in the sequence will be equal to 1 as well. How can I compute f3? Any thoughts? So what is f3? How do I get the term, the fourth term? It's f1 plus f2, exactly. So f2 plus f1 plus f0, but I already computed f2. So it's not f2 plus f1 plus f0 side, right? It's just f2 plus f1. You don't want to double count f0 twice. Yeah, it's not going all the way to 0. It's really using this definition, right? This recursive definition. F of 3 would be equal to, right? Substitute n equal to 3. So it's f of 2 plus f of 1. The two previous terms. No, it doesn't, right? Based on this sequence. Yeah. Otherwise, you will, double count other things, right? So if I close this thing. Okay, and we see f of 3, as I said, is equal to f of 2 plus f of 1. I know f of 2 is 1. I know f of 1 is also 1. We just computed f of 2, and we have already given f of 1. So that's 1 plus 1, that's 2. F of 4, any thoughts? Using this recursive definition, f of 4 is equal to f of 3 plus f of 2, exactly, right? What is f of 3? It's 2. What is f of 2? It's 1. So f of 4 should be 3, and so on. Yeah, you can define the hundredths Fibonacci number, 1000th Fibonacci number, and so on by just generating the values all the way up to 100 or 1000, right? And just summing the previous two values. Okay, so it's very recursive. Yeah, why is it recursive? Because I have some base cases, yeah, and I have to compute the function, right, or the Fibonacci number at n. I call myself or solve the problem for smaller values of n until I hit the base case. So the question, can I write a program or a function that will take n and return the Fibonacci number corresponding to this n? So if I give it 0, it should give me 0. If I give it 1, it should give me 1. If I give it 5, it should give me the Fibonacci number for 5. Yeah, so basically 5. So how do I write this using it's obviously very recursive. So how do I write this using a recursive function? What do I need to do to define a recursive function? Before let me answer Daniel's question, and then we'll get back to it. So find an f, you just have an equation of f of n equal to f of n minus 1 plus f of n minus 2, right? But I have to write this as encoding, right? So a function typically either does a loop or calls itself, until it reaches a base case. So we have two versions of a function, recursive or iterative. Yeah, and I need to be able to give it any value n, any number, integer, and should return correctly the Fibonacci number corresponding to this n. So if I give it 5, it should return 5. How do I write this? What is the steps for a recursive function? We have two steps, the base case and the recursive step. What do you think is the base case? Remember, the base case is the things I know automatically. I don't need to call myself. I can just immediately return the value. So what are the base cases? Okay, so Rawad and Adam are saying there are two base cases, for 0 and for 1. Yeah, so basically, if you give me n equal to 0, right? So the first base case is really n equal to 0. If you give me n equal to 0 in my function, I should return 0. And if you give me n equal to 1, I should return 1. Okay, so these are the two base cases. Okay, what about the recursive step? The recursive step is written here. How do I transform this into code? Python code. So if n is not equal to 0, if n is not equal to 1, what do I need to do? I need to call myself, yeah, until I hit the base cases. Okay, we've always seen this, where you have, just you call yourself once. Any thoughts? How can I do this recursive step? So if n is not equal to 0 or 1, what do I do? Let's assume the function is called f. Yeah, the function that is going to compute Fibonacci. Yeah, is f as here, right? So it's the name. So to compute for any value n greater than 1, we can have a var equal to 0, and then we do we don't need a variable. We just need to, say, call myself twice. Here's how I write it. Let's see. Let me show you. Let me clear this. Okay, so let's do the following. I'm going to import sys, right? Because I want to read the n from the command line. And let's define the function together. Fibonacci. Okay, what does it take as an argument? An integer. Okay, first the base cases. So we're gonna do the base case. Okay, what is the first base case for Fibonacci? If we use I for range, Adam, if we use I for range and range of length of f of n, first of all, length of f of n, right? F of n is a function, right? So it doesn't have a length, right? So you're assuming f of n is a list. Second thing, for loop immediately is not recursive. I want to write this recursively. Yeah. So the focus on this week is on recursion. Of course, you can write it in an iterative manner, but it's much more complicated than if you write it recursively. It's very naturally recursive. And now, anyway, right, regardless of whether you can write it iteratively, easy or not, we want to write it recursively. The focus of this week is on recursion. Yeah? So I should not see any for loops, at least without a recursion in it. Okay, so let's focus on the base case. So what is the base case? We just discussed the base cases. If n equal to 0, right? That's the first base case. What do I return? Return 0. Right? So this is the first simple case. I have another base case. If n is equal to 1, right? I should return 1. Okay. So far, so good. Now, Daniel is saying else, right? So now if I'm not in the base cases, so the recursive step. Okay. Else, what do I do? I want to return something, right? A function should always return something, right? At least if it's unless it's going to print or do something inside of it. Here we want to return the Fibonacci number. So let's return, okay. And what Rawad is saying is absolutely correct. Fibonacci of n minus 1 plus Fibonacci of n minus 2. What does this do? Let's try to understand. So I'm calling myself twice this time. Once with Fibonacci of n minus 1 and once with Fibonacci of n minus 2. So if I have the following, if I give this function the input, let's say n is equal to 3. So I call it with 3, okay? It will go here, check, is it the base case? No. Is it the base case? No. So it's gonna get into the else. And what is it going to return? It's going to return Fibonacci of 2, because n is 3, plus Fibonacci of 1. What does this do? No, nothing would change if you write else if n equal to 1. But since I'm doing return, right, I don't need an else, because return would immediately return the value and exit the rest of the program. Yeah. So I don't really need and here even I don't need an else. I could just say return immediately Fibonacci, yeah? Because, right, if it's not one of these cases, it will get into the next one. So now I don't know what the Fibonacci of 2 is, right? But this is a call to the function again. So I'm gonna open another F scope. Now I'm calling, this with the value 2. So I have Fibonacci of 2. That's another call to this, function. N is equal to 2. That's what it sees. Is n equal to 0? No. Is n equal to 1? No. It's gonna go into the else. And now it's gonna call fib, right, of 1 plus fib of 0, right? So the 2 is gonna return, is gonna, result in 2 additional calls to the function. This one I already solved because I know Fibonacci of 1 is equal to 1. So I'm gonna replace it by the value 1. So now I have 1 and I need to do computation on Fibonacci of 2. Fibonacci of 1, I know it, that's 1. And Fibonacci of 0, I know it, that's 0. And now, all of these are gonna get summed. So 1 plus 0 plus 1, it's gonna give me 2. Yeah, so this is really what happens. Let's run it and then I'll take questions. So I'm gonna do, oops. Python Fibonacci.py. Yeah, I haven't really said that I should take I haven't called the function or taken value, so integer of sys.argv 1, and then I'm going to say print Fibonacci of that. Right? So I'm calling the function, and whatever it returns, I'm going to print. That's it. So I'm going to give it, let's start with 0. Make sure that the base cases at least are correct. Okay. So if I do Fibonacci, of 0, it gives me back 0 because it hits the first base case. Let's try it on 1. It's the second base case. And yes, Fibonacci of 0 is 0 and Fibonacci of 1 is 1. Okay, let's try 2. And I should see back 1, right? Because Fibonacci, if you look at Fibonacci of 2, it's equal to 1, right? And that would result in only 2 calls, right? So when I get into the else, and then I'm going to call Fibonacci of 1 and Fibonacci of 0. I know Fibonacci of 1, that's another call to this function. It's the base case, returns 1. This one would be Fibonacci of 0, call this function again, return 0, 1 plus 0 as well. Okay, let's do Fibonacci of 3. And it gives me back 2. That's correct. Right, let's see. Put the slide here. Where's the command line? Okay, yeah. Let's call Fibonacci of 4. Gives me back 3. Fibonacci of 5. Gives me back 5. Fibonacci of 6 is going to give me 8. And so on. Right? It's working. 7, 13. 8. It's going to be, I think, 21. Okay. That's really. All right. So what shouldn't we specify if n is greater than 0? Because if it were less, then the function. Yes, of course, right? You need to look at all special cases. But again, we're really demonstrating things. So we're not going to cover everything. But in a realistic program, if you're going to use this, in practice, you would have to do some assertion, right? To make sure that your function only gets positive integers, yeah, or non-negative integers. Okay? Questions about this? The second exam is going to be heavy on recursion, yeah, and it's coming, I think, in a couple of weeks, if I'm not mistaken, or less. So you need to understand recursion very well. Please ask questions. We have a lot of time. We're doing well on schedule. So please ask questions if you don't understand what's happening. It's also a core in programming. Yeah, you really need to understand recursion. It's a very important thing in programming. Questions? Questions at all? Okay. So again, right, just to recap the code, right, we have 2 base cases. So here are 2 base cases, right? And we have 2 recursive calls. So the function calls itself twice. Yeah, that's really what's happening. Okay. Another exercise for you. I want you, please, all of you, try to solve this exercise on a paper or on your, if you have the your computer open and you have your Visual Studio or something like this, please try to think about this exercise. What is this exercise? I want to multiply elements of a list. If I don't tell you anything, just multiply elements of a list. What is the first, thought that's going to come to you? Forget about recursion, right? Assume you can do anything. How do I multiply, the elements of a list? You give me it's a function that takes a list as an input, L, and return the multiplication of all the elements inside of it. You do a loop, exactly, as Christina and everybody is saying in math. You do a loop over all the elements in the list, accumulate, right, in a product, exactly, right? You accumulate in a product, you assume product is equal to 1, and you keep multiplying the elements as you're looping. Okay, that's great. Yeah, so this is very easy to do iteratively. Can I do it recursively? So the challenge here is, can I write a function that is recursive? What does it mean recursive? It has a base case and, a recursive step. It calls itself, on a smaller input until it hits the base case and correctly multiply the elements of the list. So let's see what is the definition of a multiplication of elements of a list. It's really, L of 0 times L of 1. So the first element times the second element, all the way times L of length of L minus 1. Why length of L minus 1? Because I have the list starts from 0 and ends right before length of L. So I have 5 elements from 0 till 4. That's the definition of multiply. Okay? Do you see anything recursive here? Can I write this in terms of, multiply of L is equal to something times multiply of a smaller, version of L. So I want to write this multiply. I'm going to use M to represent of L. I'm going to write it as, right, recursively, right? So I want to focus on the recursive step. It's, something times calling myself again, so multiply of, some other input. Okay. So okay, I'm seeing some solutions. L of 0 times L of 1 till the end. Okay, but not times like this. I need to call myself. Remember when we talked about A times B? We said A times B is really A plus A plus A, B times, right? Which is A plus, A times B minus 1. Same thing, the same logic can appear. Let's see it this way. I see Muhammad has said it, right, correctly. So he's saying the following. It's L of 0, right, times call multiply again with all the elements starting from 1 till the end. Let's analyze this, right? So the only issue with what Muhammad said is that he's trying to multiply L of 0 with the list, right? And that doesn't work, right? That will give you concatenation. So whatever the value of L of 0, you'll concatenate the list multiple times. Yeah. So you need to call yourself. A recursive step means you call your function again. So what is this saying? It's saying that the multiplying of a list of elements is nothing more than taking the first element and multiplying it with the product of all the elements starting from 1 till the end. Yeah. So really, I broke the problem into recursively into the following, right? Saying, okay, you give me any list, which has 5 elements. To multiply these elements, I'm gonna take the first element, multiply it with the product of the multiplication of the rest of the other elements. So it's as if I did brackets here, right? So it says multiply of L is equal to L of 0 plus, times the product of all the other elements. What is this? That's the same problem, which is, multiply of L, but starting from element 1 till the end. That I can do using slicing. Okay, where's the base case? So great, I can do this recursively. That's great, but I have to hit a base case. I'll keep slicing. You didn't really understand. Okay, let's try it again, Christine. So what is this function, right? This function, do you understand what it's trying to do? This multiply, it will take a list like the following, right? 1, let's say, 3, 5, and 4. Okay, so it takes for a list of, let's say, 4 elements. What is its job? Its job is to return 1 times 3 times 5 times 4. Yeah, so that's 60. Okay, now I'm saying the following. I can express multiply. Of course, I can do a loop, and keep multiplying these elements. But I want to solve this recursively. What does it mean recursively? I want to solve this problem using smaller instances of the same problem. Okay, so I'm defining multiply of L, right, which is ideally going to be 1 times 3 times 5 times 4, right? That's, if you give me this input, that's really the product I want to return. Okay, I'm doing the following observation. This 1 times 3 times 5 times 4 is really this, right? It's 1 times 3 times 5 times 4. What is 1 in terms of this list? Can you express 1 from, the list? What is it? It's L of 0, right? It's this guy. That's 1. And what is 3 times 5 times 4? It's the multiplication, right, of all the elements. So 3 and 5 and 4 are the elements, L. These guys are L from 1 till the end, right? That's slicing. What is this going to give me? It's going to give me the elements starting from element 1 all the way till the end. And what is this, right? This operation. It's really the product, right? The multiply, the function that I want to create. So it's really multiplying, right? 3 times 5 times 4. Yeah. I hope it's clear now. Ask questions if it's still not clear, or turn your mic on and we can discuss this. Okay? Is it clear now? Okay, good. Okay, great, Chrissy. Okay, so I saw you wrote some comments. Let me check them out. Okay, what do we have here? The base case, Michelle is saying when length of L is equal to 1, that's the base case. Perfect, right? If length of L equal, Daniel is also saying the same, right? Return L of 0. Adam is saying L of 0. Yes, but what do you mean L of 0? You mean, right, basically when I have only one element in the list. And then Rawad is saying L of I times L of I plus 1. I don't understand what you're saying, Rawad. So again, I want to write a recursive function, meaning I have to call myself. So I call myself how? By writing, solving the problem on a smaller instance. The list, was from 0 till the end. Now I'm gonna call myself on the list from the first element till the end and multiply it by the first element. And now the next list would come, right? The function would see it as, n-1 elements. It will multiply the second element with, calling myself on the rest of the list, which is from element 3 onwards, and so on. Again, I don't understand your comment. The functions for those elements, I mean. Let's see the code, and then if it's not clear, we can discuss this first. Okay. So here's what, right? How I write this recursively, as we said. So we multiply. You give me a list L. I'm gonna multiply the first element with the product or multiplication of all the elements from 1 till the end. Okay. The base case, as all of you said, when I have only one element, what should I return? I should return L of 0. So if I add one element, the product is just this L. Yeah. The recursive step, so when length of L is greater than 1, 2, 3, 10, doesn't matter. All I have to do is return L of 0 and then apply the function again on the elements from 1 to the end. Okay, that's really the pseudocode. Yeah, this is the algorithm. Here's the function, here's the code itself. I'm gonna define the function multiply of L, and then I'm gonna say, okay, the base case, L, the length of L, so it has one element, you just return this element, else return L of 0. Take the first element out of this list, multiply L from 1 to the end. So if I call it on, let's say the following. One, 3, 5, 4, right? So if I give this as an input to the function, let's try to trace it quickly. Yeah, it's gonna check, is the length of L equal to 1? No, it's 4. So it's gonna get into the else. So it's gonna say return 1 times, call the function again with the following list, 3, 5, and 4. Okay, so now I've reduced the input a little bit. And as you see, I keep reducing it until I hit the base case. So now I'm calling the function with 3, 5, and 4. Now L, right, in the second call is 3, 5, and 4. Is the length of L equal to 1? No, it's not. Right, so I'm gonna get here, and I'm gonna multiply, 3. So L of 0. Now it sees L as this, right? All it sees is that it has 3, 5, and 4. So it's gonna take 3 out and say times M of 5 and 4. Right? So now I have 2 elements, and I'm calling the function again on it. Now, the scope of this call, right? Remember, I open as function scope for each function call. L is equal to 5 and 4. It has 2 elements. Is the length of L equal to 1? No. So I'm going to, replace this by, go to the else. Where's the first element in this list 5 and 4, it's 5. So it's going to multiply 5 times m of 4. Okay. So now I have a list. I'm inputting a list with just one element. That's really the base case. Right? So I'm going to go here. I have a list L, which has only one element, 4. Is the length of L equal to 1? Yes. So I'm going to return 4. And now this 4 is going to be returned to the caller. So it's going to be multiplied by 5. Right? So now it's 20. Then this 20 is going to be returned to the caller, the previous call. So I keep closing the F scopes that have been opening. So 4 times 5 is 20 times 3, 60. Then I'm going to multiply 60 by 1. And then I'm going to return this to the final caller. Okay, how do what? Again, I just explained it. So multiply of L1 means call the function, right? Take the L of 1. So what did you give me here? 1, 3, 5, 4. What is L of 1 till the end? It's this 3 elements, right? So those 3 elements. So the first time it's going to be these 3 elements, and it's going to solve the problem again. Takes this function, try to multiply, as if it has a new list, as if you give it only 3, 5, and 4. It sees, is this the base case? No. Then it will go inside the else. And now it has, multiply again a call on a smaller list, which is this, right? Which is this one, right? 5 and 4. Okay, now again, this is as if you're calling the function the first time with just a list of 2 elements. That also not the base case. So it's going to try to reduce it. So now it's going to call it on the 4. And now it knows how to solve this problem, right? So there's not going to be get into the else. It sees a list, right? As if this is the first call of the function. A list with just one element, 4. So it's going to return this 4, right? And now these scopes keep closing. So the 4 will be returned to the previous one, which is 4 times 5, and that's 20. And then this 20 is going to be returned to whoever called this, and that's 20 times 3, 60, and so on. Yeah, this is really how it works. You need to be able to abstract the thinking of recursion. Well, how do I do that, right? I really need to start thinking, believing that recursion works. Yeah? So don't try to obsess too much about it. Why is it working? It's working because, as I said, right, it keeps trying to, it keeps opening these F scopes. But what you need to do, the skill you need to learn is to start, abstracting this in your head. You don't need to imagine how it's working, but you need to understand, right, that, okay, I need to call, I need a base case, and I need to be able to define a recursive step that leads me to the base case. Yeah. How do I take, my input, reduce it so that I get to the base case? And reducing it means, calling the function again, right? The recursive step, but with a smaller input. Yeah, and smaller input means, an input that leads me eventually to the base case. Okay, let's run it. All right, clear all drawings, close the thing, and we are at the, which one? What is it called? Multiply, yeah? Just multiply. Okay, here's the function that we have. Let's try it out. So I have, the base case, and as we said, the recursive step. Here, Python, multiply. And as you see, it gives me 12 because I have the elements 1 times 3 times 4, which is 12. Let's try 5. What should it give me? It should give me 60, right? And so on. And try it for anything you want. Now, here's what I want you to do. I want you to, we have talked about, maybe two programs so far. I want you to download them. They are on Moodle, and try to, understand them. Run them, run with different inputs, and try to imagine, even take a piece of paper and try to do, trace the input. Open this F scope to say, okay, I'm going to call the function with 1, 3, 4, 5. Do something like this on a piece of paper. Yeah, say okay. The function, the first time I called it, right? So M scope, you have L is equal to L here is right 1, 3, 4, 5, something like we did in previous slides, right? So 1, 3, 4, 5, and then okay, trace it on this input. So now look at it. Okay, so here is that first time I called this function, this first call. Okay, I have L 1, 3, 4, 5. Did I hit the base case? No. I'm gonna go here and return right L of 0. What is L of 0? It's 1 times right. Calling the function again and slice from the element 1. So I'm gonna slice. So I get 3, 4, and 5. Okay, what does this do? When I call this function, it's going to immediately open another scope. Right.
Professor, I just have one question.
Yeah, give me a second and then I'll take it.
Yeah, okay.
And now here I have L in the second call, right? This guy, this is L, right? It sees L as 3, 4, and 5. Okay, is this the base case? No. Right, what is it going to return? It's going to return 3 times M of right, 4 and 5 because I'm slicing from the excluding the first element, the element at position 2. What is this going to do? It's going to open another scope and so on. Trace it until you finish, you hit the base case, and then trace back. Remember, you close the scopes and as you return the values, you go back right to the caller until you hit the values. And that's really how it's executed in Python. Right? It uses something called stack, which you will see in next programming course. Okay. Yes. So who had a question? Please turn on your mic again. And
yeah. Like I got the idea, but when you're saying it's repeating itself, the sec M scope, you're doing it again. It's like a new list.
Yeah.
Suppose by then we got to the end, which is 5.
Yeah.
And now it is the base case. We insert length equal to 1. So why doesn't it return 5 هيك لحال?
Because it returns 5 to whom? To the one who called it. Who was the one who called it? The one who called it was this, right? 3, it returned 4 times 5, correct? It doesn't return 5 to immediately to the first, to the global scope, right? It has to go back, right? I moved here, step, 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 step. I have to go back the same step, trace back the same steps. So I'm going to return 5 to whoever called me. The one who called me was waiting to multiply 4 times the solution of multiplying a list which contains only 5. So it's going to multiply 5 by 4. Now we have 20. 20 is going to be returned to whom? To the previous caller. Yeah, that's why I'm telling you, as soon as you call the function, right, you open a new scope and you trace these scopes forward until you hit the base case, and then backward until you hit, you go back to the caller. Let's see this again. I'll show you. I don't have it on the multiply, but I can show you what I mean again. Give me a second.
Okay. Yeah, because I thought about it like in the wrong way. I thought that it's gonna do 1 times 3 times 4 times 5, then 3 times 4 times 5, then 4 times 5, like into all the values of these.
No, let's see, an example of what I mean by this F scopes. Remember the what is it called? The factorial, right? Let's see the factorial, how it works. It's exactly the same. Here's the factorial, right? I have, I give it the value 5. It checks is 5, the base case. So let's assume I'm calling factorial of 4. That's the global, scope. Yeah. So I have factorial. It's just a function that is corresponding to some code in memory. And then as soon as I see fact of 4, I'm calling the function with the value 4, right? That, triggers opening the fact scope. So I'm going to open the fact scope. What is the value of n right now? It's 4. Yeah, that's what it sees. Okay. I'll check now, execute this code, because now I'm in the fact scope. I have to execute the code of fact. Is n equal to 1? No, 4 is not equal to 1. So I have to return 4 times factorial of 3. That's what it's going to do. What is factorial of 3 now? It's as if I'm calling the function again, with a new value of n. N is equal to 3. So that will trigger, a new scope. So, now n is equal to 3 in that scope, and that's all it sees, right? It doesn't see anything from before. It just sees that n is equal to 3, and it will execute the function again from scratch. Is 3 equal to 1? No. So it's going to return 3 times factorial of 2. What would factorial of 2? Opens another scope, with n equal to 2. Again, this is not the base case, so it's going to return 2 times factorial of 1. Factorial of 1, what does it do? It opens another f scope. Now n is equal to 1. Is this the base case? Yes, n is equal to 1. I know what to do. I immediately return 1. So I wouldn't open a new f scope because I have, I'm not getting into the else. I'm just saying return 1. Return 1 to who? I don't return 1 directly here, right? No, I return it to whoever called me. This is the one who called me. So I replace this factorial of 1 by the value 1. Okay, so now I have 2 times 1. Now I can return this value. It's a number, right? So now I can return 2 times 1. Who I return it to? To the one who called. So that's 2, right? Then I do 2 times 3. That's 6. Who I return 2? To the one who called me. So I replace factorial of 3 by 6. And then return 6 times 4. That's 24. So I'm going to replace this by 20. So that's really how it works. Go until you hit the base case. Backtrack, using the same path until you reach whoever initially called the whole function, triggered the whole function. Yeah, and keep returning these values as you go. Same thing for the list. I want you to do the same thing at this slide for the list. Take an example of a list of 4 or 5 elements. Try to see, what is it doing step by step, and then trace back until you get to the value. That way you will understand exactly what is it. Okay, let me see if you had some questions. Where is the more chat? Okay. Okay. Could we have a code that requires, for example, recursion and loops? Yes. And I think that in the assignment there are some examples on this. Maybe we can do one next week. So you can do some a recursive function that has a loop inside of it, or vice versa. You have a loop and then some recursion inside of it, right? So we'll look at this in some other examples. Okay. What else? Other questions? Okay. Let's see. The next one is, okay. This one is easy. Let's do it and then we'll repeat it again the next time. Last exercise for today. Yeah, the factorial is from one day. I was trying to show you how to trace the function. Okay, so let's do the following exercise, or at least start thinking about it, and then we can discuss the solution on Friday. So palindrome, who remembers what is a palindrome? Can anybody give me an example of a palindrome? It's a string, yeah? So what is it? Madam, yeah. Or something, Bob, or, yeah? No, exactly. So what is that? I, yes, perfect, right? What is it? It's a word that you can read it from left to right, similarly, right? So like I, laughing out loud, yes, right? Level, all of these, you can read it from right? Okay, or shady, yeah, okay, good example that uses my name. That's perfect. Okay, good. So we already did this recursive, iteratively, yeah. So we look at a loop over the elements inside the list, or even you didn't have to loop, you were using slicing or something like this, yeah. So we're trying to look at, okay, if the first letter and the last letter are the same, yeah. If that's true, great, right? Then you can continue with that sublist from the second element till the element before the end, and you keep doing this iteratively, yeah. But can we do this recursively? It's really, I already said the solution. If you give me if I give you a string S, yeah, S, okay. I want to check whether it's palindrome or not. So I'm gonna define a function called pal. Let's say takes a string S and decides whether it's palindrome or not. Okay. How do you think you could do this recursively? What does it mean recursively? It means, try to take S, reduce it a little bit, and solve again, on this substring, yeah, by calling the function again. Let's see, for instance, something like ABBA, a good band. If I doubt you're familiar with it. The oldest among you is 20. You probably have no idea who the ABBA is, but it's a great band, Swedish band. Okay, yeah, Jad is a fan as well. Okay, so ABBA, right, is obviously a palindrome. Can you think of a way of solving this problem recursively? So imagine this function pal takes ABBA. Okay. Other thoughts? So Rawad has some thought. Any other thoughts? Anybody else? So you have, yeah. I'll comment on your suggestion, Rawad. But let me see if anybody else has other thoughts or similar thoughts or something. So imagine. Okay, so Adam is thinking about the base case, right? Yes. Okay, so saying the base case is one character. But let's focus on the recursive step. Imagine the following app, right? What can I do? I can check the following. So I just think she agrees with Rawad. I also agree with Rawad. What Rawad is saying, yes. Khalid is saying, okay, check S0 is equal to S minus 1. So basically the first character and the last character. So I'm going to check these two guys, right? Are they the same or not? And solve the same problem now for the substring. So take the first two letters, the first letter and the last letter, make sure they're the same. And if they are the same, now all you have to solve is to check whether the substring from the second character to the character before the end is palindrome, right? And that would do what? We'll strip these two characters and see if you have a palindrome in between. And you keep doing this over and over and over until you hit the base case. What is the base case? The base case somebody said, which is a string with one character. If you give me one character C, it should that's palindrome by definition. That's great thinking. Try to think about it a little bit. Of course, you have the slides, you have the code already on Moodle, but we'll do it on Friday. We'll start writing the code on Friday and run it and analyze it, etc. And then we have one more exercise, which is towers of Hanoi. That's probably going to take us the rest of the lecture on Friday. Okay, thank you, everyone. Please try out these few examples that we've discussed today. Yeah, try it out, with different inputs. Try to trace it and understand what is it do. Okay, you can also start on the assignment if you haven't already. Right. Good day.